Hi folks, welcome to the 9.2 video. This section we're going to be talking about arithmetic sequences. Alright, so let's get started. What is an arithmetic sequence? So an arithmetic sequence is a sequence of numbers where it is going to be increasing or decreasing by the same number every time, okay? So this same number that we're increasing or decreasing by is D, and D is called the common difference. Now, for example, you could have a set of numbers. Maybe it would be like 2, 5, and then 8, and then 11, and then 14, and then it kept going. So what is the pattern that's happening here? Well, each time I go up a number, I'm adding 3. So 5 plus 3 gives me 8. 8 plus 3 gives me 11. 11 plus 3 gives me 14. So this number, this plus 3, that's our common difference. Now, if I were to plot this and think about plotting points, okay, not a line, but points, I would know that a sub 1 is 2, and a sub 2 is 5, and a sub 3 is 8, and a sub 4 is 11. And so what I end up getting is a linear function, okay? So an arithmetic sequence is linear in shape. So in this case, my common difference was a plus 3, and the slope of this line is a positive 3. So the common difference and the slope of a linear function are the same thing. Now let's take a different set of numbers. Let's say that we had 100, and then I had 99, and then I had 98, and then 97, and then I kept going. What is our common difference here? Well, I subtract 1. I subtract 1. I subtract 1. And so all of these are the same, which means that I have a common difference of negative 1. Now, what happens if we plot these points? Well, this time we'd have to start up at 100 and then go down to 99 and then 98 and then 97 and then 96. And so you can see that this line has a negative slope. And as it turns out, the slope of this line is negative 1. So this common difference is negative 1, and that also means the slope of the line is negative 1. So common difference, I want you to imagine in your head, is like the slope of a linear function, okay? And we can find out whether things have a common difference or not if we always add or subtract the same number. Okay, so let's take a look at a formula to help us find any term or the nth term of an arithmetic sequence. This formula is very much like our y equals mx plus b. So I have y equals mx plus b, okay? So this common difference, again, is like our slope. And our x values are whatever we plug in for n minus 1. And the first term is our starting point. So in general, we can also refine it to say something like this. A sub n equals a sub k plus n minus k times d. Now, I have to say that in the variety of textbooks I've looked at, I would actually say that this one is the more common formula, okay? So it might be worth investing in this first formula rather than the second one. Another name for this kind of formula, it is called an explicit formula, or sometimes it's referred to as a closed formula. All right, so explicit or closed means that you can find any term you want pretty easily just by plugging in n. Okay, so let's take a look at some examples. So example number 1 says the first three terms of an arithmetic sequence are 20, 16.5, and 13. And the question is find the 15th term, or a sub 15. So let's see how this would work. I'm going to go ahead and start by finding my common difference, okay? So I noticed that to go from 20 to 16.5, I have to subtract 3.5. And when I go from 16 to 13, I also subtract 3.5. So what that tells me is that my D equals negative 3.5, okay? So if I am going down by 3.5 every time, that means I'm going to have a slope of negative 3.5. So let's go back to our formula. Y equals a sub 1 plus n minus 1 times d. And let's see what we get for our y. So a sub 15, because that's what we want to find, is going to be my first term, which is 20, plus, remember, everywhere you sub in 15 for n, you got to plug in 15 for n. So 15 minus 1 times my common difference that I found earlier. All right, I'm going to plug in negative 3.5. And I can do 20 plus 14 times negative 3.5. And let's see what that gets us. That gets us a total of negative 29. So that means that the 15th term is negative 29. Okay. Now, you can go ahead and just keep subtracting 3.5. So you do 20, 16.5, 13. What would the next term be? Minus 3.5. It's going to give me 9.5. Okay? And I could keep going until I get to the 15th term. That's a good way to kind of check your answers when the numbers are small. But if I asked you to find the 100th term, you probably don't want to sit and write out 100 terms. It's probably better to use the formula. Okay? All right. So let's go ahead and take a look at example number 2. So example number 2 says that if the 4th term of a sequence is 5 and the 9th term is 20, they want us to find the 1st and the 6th term. So I'm going to draw a little diagram to help myself get started, okay? So I have the 1st term, the 2nd term, the 3rd term. I know the 4th term is 5, or a sub 4 is 5. I have the 5th term, the 6th term, the 7th term, the 8th term, and the 9th term is 20, or a sub 9 equals 20. And what I want to find is I want to find a sub 1 and a sub 6, okay? So let's go ahead and plug in what we have. So I know that I have 1, 2, 3, 4, 5 spaces between 5 and 20, okay? So let's find out what the difference is. 20 minus 5 gives me 15. And what number goes into 15 5 times? So 15 divided by 5 gives me 3. Now let's see, if I take 5 and I add 3 every time, will I get to 20 by the time I've added it 5 times? Well, 5 plus 3 will give me 8, 8 plus 3 will give me 11. 11 plus 3 will give me 14. 14 plus 3 will give me 17. 17 plus 3 gives me 20. Good, okay. So this is one strategy that you can use to help yourself find the missing term, okay? So you can figure out how much space you have between the two. That's your 20 minus 5. And then you divide it by how many times you would have to add that number, or 5. Now, if I have a sub 4, I can just count backwards to find my a sub 1. So I'm not going to add 3, I'm going to subtract 3. So 5 minus 3 gives me 2. 2 minus 3 gives me negative 1. And negative 1 minus 3 gives me negative 4. Okay? So that means that I end up with an a sub 1 of negative 4 and an a sub 6 of 11. All right? And that's not a bad strategy to have. I think it works pretty often where you can just kind of see how many spaces you have and write it out and think about it rather than trying to memorize a formula. Okay? All right, so we're going to stop here for this video. When we come back, we're going to talk about arithmetic series. Okay, so not arithmetic sequences, but arithmetic series. All right, I'll see you back here for part 2 of 9.2.